this is how you test for assumptions of a linear regression model. For example, test for linearity, test for normality, test for multicollinearity, and test for homoscedasticity. Yeah. So after running a regression model, for example, miles per gallon predicted by price and maybe weight, and then run the model, you would go on to check for linearity, maybe to see if the independent variables are linear or not. So in that case, I'll use a CPR plot, and I'll pass in variable by variable. So I'll check variable by variable. So go saving. So this is I'm going to save it as CPR price, and then run it. So it will generate a plot that looks similar to this. So the line that you see, the line which is not straight, is predicts the path of the price, and then the line which is straight is the ideal where this line should pass. So if this line deviates so much away from the straight line, it means that it's not linear enough and it might require some kind of transformation. Then I'll just borrow this command again and then test for weight to see. So I'll just put weight here and then save it as weight, save it somewhere. Then as you can see, the weight curve also, all the component plus residuals for weight deviate away from the straight line. So in that case, such variables might need some kind of transformation. Yeah. Then let's check for homogeneity of variance, or what we call homoscedasticity. So we shall first predict for maybe the outcome. Maybe we can call it MPG fit. Yeah, we want to look at the fitted values of MPG, so which you can see here, and then we shall generate some residuals, predict, we shall call them resid, and they will be generated as residuals. Yeah, as you can see, they are generated right here. Yeah, so now let's try to plot a scatter, or let's first get a summary of these residuals, and we see, as you can see, the minimum and maximum are those. So let's see how these residuals are scattered, and we shall plot them against MPG fit. And then this Y line, let's just limit our values between maybe -3, 0, and 3. We shall put those lines and then we see. So as you can see, there are some good values that are outside our limits, which might imply that these residuals are not, maybe there's no homogeneity or variance. So let's confirm that by running a test by istat. Yeah, this will be a Bruce-Pagan test for homogeneity. Yeah, so this test confirms that we are failing to reject. We are rejecting the null hypothesis. Yeah, since the p-value is less than the significance level of 0.05. Yeah, which implies that we are going to reject the null hypothesis of constant variance, as it was shown in the graph that the points are so much scattered away from the limits. So this implies that there is heteroscedasticity in the model and the variance is not constant, hence violating that assumption. So you might run some robust standard errors to get rid of that. Yeah, let's try to test for normality. So the normality shall be tested using the p-norm curve, and we shall test them on the residuals to find out Yeah, so as you can see, this line, the dotted line, deviates a little bit away. It's not so much close to the straight line, which might also imply that they are not as normal as we might expect. And they might also need some kind of maybe to check for some things and rectify them. We can also test for multicollinearity by running a variance inflation factor command, and it will generate for you the variance inflation factors for the different variables in independent variables in the model. As you can see, if we take a threshold of 5, there is no evidence of multicollinearity in the model. Yeah, that's how you can check for those assumptions and verify them for a linear model. Thank you.